Hey everyone, welcome back to the channel and let's solve one more union find problem today. So today we're going to solve Leetcode 947, which is most stones removed with the same row or column. So we're given a 2D plane and we're also given X number of stones, and we are asked to remove the stone which share a row or the column with some other stone, and then we need to find the maximum number of stones which can be removed, and we're expected to return that number. So in this question, we will make use of the union find data structure, and it's something which is really gonna help you understand how to use the union find in conjunction with some other data structures. So let's have a look at the drawing board with this particular example, and then we will try to see how to solve this problem. So we're given the first example, and that's what we're trying to solve over here. So I put the points which is given in the first example on a graph, and as we can see, these are the different stones at the different points. Now, as the question says, we would try to remove some of those points which already have some stone in the same column or in the same row. So from here we can see that we can remove stone number 5 because there's already stone number 3 in that particular row, so we can remove this. Then we see that we already have stone number 3 and 2 in the same column, so we can remove stone number 3. Then we also see that we have stone number 1 and stone number 4 in the same row, so we can remove stone number 4, and stone number 0 and 2 also they share the same row, so we can remove stone number 2. And then stone number 1 also shares the same column with stone number 0, so we can remove this as well. So how many stones have we removed in total? That's 1, 2, 3, 4, and 5, which is the expected answer. Now, what if we go the other way around to this question? So what happens is we will place the first stone, which is the stone number 0 in this case, and then we will just make sure that that particular row and that particular column gets occupied, and for every other stone which we're going to place, we will just check that if it lies in the same row or the same column, we will just increment that number of the stones to be removed, and we will just make sure that if you place another stone in that particular row or that particular column, we're going to remove that as well. So we're going to go in a bottom up fashion. Let's see an example how to do that. So it's the same example, but we're trying to do this in one different fashion, the bottom up one, which I just talked about. So we have the first stone, which is stone number 0. What I'm going to do is I will be having two different hash map, which is be x and y. X will store the x coordinates of the stone, and y will be storing the y coordinate of those particular stones. So we're going to process these nodes one by one, and we will be using the union find data structure just to make a record of which all stones have been joined and which stone is a representative of that particular set. In case I've already not seen the previous video, I would strongly recommend you to go through that, which will explain you the theoretical parts of the union find or the disjoint set unit data structure. But yeah, that's what we will be using in this particular example. So now let's go ahead and see how do we do this. So we process the first stone, we put the value 0, which from here into this x map. Okay, we have put that over here. Now we will just see if it is also possible to union the y coordinate. So we have 0 and 0, but yeah, there is no other stone which has already occupied, so we just leave it at that in that same fashion. Then we will just mark this as process. Now we move on to the other stone, which is 0, 1, stone number 1. Here we see that the x of 0 is already occupied. Okay, so in that case, what we're gonna do is we will just union the stone with the stone which is represented by the index of that particular key. So we see that 0 is mapped to 0. Now here 0 is the index of the stone which I need to map it with, which is this particular stone. So now what I'm gonna do is I will just map this stone to point to this stone. Okay, now we're gonna check it for the y coordinate. 1 doesn't exist, so I will just add 1 over here, and 1 will now be pointing to the index of the stone, which is 1, and that's it. Now we have processed this stone, and we'll also be adding 1 to removed because we were able to union one stone, and then whenever we do that, we will add 1 to the removed one. Now coming on to the other stone, I'll just mark this as processed. Now we move on to the another stone, which is 1 comma 0. Here what happens is 1 is there in x, it is not there. So what I'm gonna do is I will just add 1 and it will now point to 2, which is the index of the stone. Then I go to y. Now is 0 over there? Yes, 0 is already there and it points to the 0th stone. So what I'm gonna do is I will now be trying to union this with the 0th stone, which is this stone. And whenever I do that, I will add the number 1 to the removed total value. And we're done with this. No, not yet. We checked the 0th value, it's already marked. We checked the x value, it was already there. So yeah, now we're done with this. We can just mark this as done. Now let's move on to the other stone. So the other stone has the x as 1. 1 is already occupied. X. So what we're gonna do is we will now union this with the stone which has the index of 2. So the stone which index of 2 is 1 comma 0, and we will be now trying to union this together, and we will add 1 over here. Okay, and now coming on to 2. So 2 is not there in y, so we're gonna put 2 over here. So the reason why we do put these values in the hash map is because the next time when we're trying to place a stone, we just know that there is a stone with that particular x and y coordinate already scanned, so we don't really do that. Rather, we will do the union find step over here. So we're done with the stone number 3 as well. We will now just mark it as processed. Now we go on to stone number 2 comma 1. Is 2 there in x? It is not there. So what I'm gonna do is I'm just gonna put 2 as 4. Okay, now 1 is there in y? Yes, 1 is there in y, and it points to stone with the index of 1, and the sum of indexes 1 is 0 1. So I will now try to union this with this stone, which is 0 and 1. So yeah, it is this stone over here, and we will just draw this, right? And so we have processed the second y coordinate as well, and now we will just mark this node as processed. And yeah, just forgot, I will just add 1 to my removed as well. Okay, now coming back to the stone 2 comma 2. 2 is already there in x, so I will now this time it points to 4, which is 2 comma 1. So now what I'm gonna do is I will just union these together. I will add 1. Okay, now moving on to the y coordinate 2. So 2 is already there, which is 3. Points to 3, but if we try to union these two nodes together, so the node 3 is 1 comma 2, the parent of this node is 0 comma 0, and the parent of this node is also 0 comma 0. So this time we won't really union because these two nodes are already been union before. So in that case we won't really add something to the removed total value. So the value of this removed is, if we were able to successfully union two nodes, we're gonna add 1 to the removed counter, else we're gonna add 0 to that. So that's the reason why we will keep the union find data structure, just to make sure that whether the nodes which you're trying to group together, have they already been grouped together. So that's one of the reasons why union find, this powerful data structure, is helping us achieve this. So this is the core code behind this problem, and let's now have a look at the Python code for this problem. So now let's have a look at the code for the problem. So we're gonna start with defining the rank and the parent list which we need for our union find. So we self.parent, which will be an empty list for now. Along with that, we'll have self.rank, which will also be an empty list for now. Then we have the find parent method, which is gonna take just a single node. Let's keep that to be x, and if x is self.parent of x, then we will return x, else we do the path compression. So self.parent of x is equal to self.find parent of self.parent of x. So we do the path compression, and after that we just return the parent of x. We're done with the find parent. Let's do the union step now. We take two nodes, x and y. Then we take the parent of x. That's the next step. So self.find parent of x, and parent of y will be self.find parent of y. And now if these two nodes are already together, or we have performed the union step, which is this condition, we're just going to return false or the numeric value of 0. And then now we're not okay, so now we're at this step where we just want to union these two nodes, and we do that by the rank. So first step is to do the optimization and make sure that the element with which has the parent of x is the larger one, and then we're gonna join the smaller one to this particular component, and we just do that with this line of code. So parent of x is smaller than, then we just swap those two values together, parent of y, and this will be parent of x. So we have done that, and now it's just two lines of code. So self.rank parent of x. Now we're just gonna add that to the rank which we have for this, which is gonna be parent of y. So we're just adding the rank of the component which is represented by parent of y. We're just adding that to parent of x because we're now adding this entire component to the one which is headed by the parent of x. And then we also need to change the parent of y, so because that now has a new parent which is parent of x, and so we're done with all this. We just return true just to indicate that this union was successfully completed. So we're done with the union find steps. Now let's come to the core function or the method, and here we're gonna take the length of the stones in a variable, and then we're just gonna initialize our parent and rank list. So this is gonna be I for I in range of n. So all this, the theoretical part of the union find, we've already seen in the last video, so I would strongly recommend you to check that if you have already not seen that video. It will really help you in learning the concepts, and we're just using those over here. So we're done with the initialization of the parent and rank. Now we will need two lists, which is going to be x and y, and x will store the rows, so x will store x stores the rows which have been occupied, and similarly y will stores the columns which have been occupied, and we will use these to check if some stone is there in that particular row or column, and then we will do the union step. Just as we have seen in the explanation. Now we're going to iterate over all the stones, and along with that we will also take the index of that particular stone, because when we do the union find operations, we will use the index of that particular stone in order to refer to that stone. So we're going to enumerate over these stones. Now every stone is of this format, so every stone looks like so we have the stones something like this, 2, 3. So suppose we are going over this, so this is the first element, so index would be 0, x would be 1, and y would be 2. Similarly for this one, I would be 1 because we are the second index, x will be 2, and y would be 3. So this is how we will be iterating over these stones. Now first step to check is if x in x. Okay, so if this row is something which we have already seen, well, if that is the case, then we're gonna store it somewhere. So let me just declare the count variable as well. I didn't do that. We will store the number of stones which were removed in this count variable, and we will be using it over here. So if x in x, it definitely means that we just want to union this particular stone with the one which is already there in that particular row, and here we find I and x of x, so we will get the index of the stone which is already there in this row, which is represented by x, by this notation, and I has the index of the stone which we are currently iterating over. So this will make sure that we have that in the count, and it might be 0 because the reason is we might have already performed the union operation on this stone. In that case, we just want to skip it, so we're just putting it using this value. If it's possible to union this, this function is going to return true, which will be converted to a numeric value of 1, and if it's not possible, false will return a numeric value of 0, and accordingly count will be incremented, or we won't be incrementing it if it's not possible to union them because they have already been unioned before. Similarly, now if it is not the case, then we want to make sure that we're placing this stone. Now we want to keep a record of this stone so that for the next stones we would just union this stone with those which are to be placed in this particular row. We do the same thing for the column as well. If y and y, then we're gonna increment the count. Count will be count plus self dot union of I and y of y, and if that is not the case, we're just gonna update the y with the index of the stone, and this is how we make sure that we just place those stones who just keep the constraint true, and we just place a single stone in a particular row or column. And once we're done with this loop, we will have the total number of stones which have been removed in this count variable, and then we can simply return the count value itself. So because that's the number of stone which we skipped to place on the graph or on the 2D plane, because we were able to already place some stone which was already there previously. Now let's try to run this code. It should work. Okay, we're having a thing. Okay, let's run again. It should work, and let's try submitting it. Perfect, it worked, and okay, it's a pretty efficient solution. We're able to beat 99% of the other submissions. So yeah guys, this is about it. The question, we're done with that, and we'll be doing more questions in the series. And if you have any issues or if you would like to point out something, feel free to drop it in the comments below. Also, please like, share and subscribe to the channel. It really helps us a lot. I'll see you guys very soon in another video. Bye bye till then.